All right, we are in Precalculus on our second to last lesson of our entire unit. We're interpreting equations graphically for lesson 2-5. Today's date is Thursday, November 19th, 2020. All right, our objective today is to do what? With a quiet raised hand. Leo. There it is. I mean, everything today is how to find solutions. It's the intermediate step. Instead of actually making you find the solutions right now, all I'm doing is saying, hey, like point to where the solution is. Tomorrow, you're going to be telling me, oh, the solution is 5 or it's -3. And you have to you're responsible for making the graphs. So everything that you've learned graphically, how to make absolute value equation, the cubic equation, all these different not sinusoidal, but basically every equation that I've ever taught you, a logarithmic, exponential, every single type of graph is free game tomorrow. You have to remember how to make all of them. So that's why it's going to be a longer lesson. So let me talk about just my perspective on what does this equation mean. Notice that I'm using t instead of x, and it's just, I'm trying to match it like Khan Academy to make it less friction when you guys are actually doing the homework and the tests and stuff like that. So if I say f of t, just the function is 2 to the power of t minus t squared. This is an exponential minus a quadratic. What's happening? So this function is really represent all the heights for values of t. So that's the key word that I want to be using today, heights. So if I'm looking at, this is again is the blue equation over here. This blue equation, while it does look like a cubic, it's actually this equation, which is an exponential minus a quadratic. This blue equation here represents every single height for every value of t. So if I'm talking about, if I plug in t is equal to 1, then I'm saying, what is the height? The height is 1. You can give me any value of t as an input, and I will output a y value, which is the official term, but I'm really thinking, what is the height? You'll realize why this is helpful in a second. So when I'm asking you questions down here, the equal to sign equals 0, equals 1, equals something. The equal to sign is really asking you guys a question. The question is, at what value of t, or whatever your input variable is, it might be x, at what value of t for our lesson today are the y coordinates the same? Or are the heights the same? And this is the same form of translation that you're going to have down here. Notice you have a table that says, here's your equation, what's the translation, and then even more, what is the solution? And then the solution will always be t values. So, and I really want to emphasize this point. Please circle, highlight, star this. It's the t values. At what t values are they the same? And I forgot my end parentheses, didn't I? I started my quotes over here, and I didn't end my quotes, so I should have my quotes right there. Sorry about that. What are my t values? So every single one of these, the solution, you're going to write t equals something. You're not going to write y equals. You will always, always write t equals. So I don't forget, my first thing that I'm going to write down here is t is equal to. You'll never have a y value for your answer. There will be trick questions on Khan Academy that says, what is the answer? They'll have a list of t values and a list of y values. Ignore the y values. It's really asking for values of t. So I've given you a hint for some of the questions that will pop up today. All right, let's look at this first equation. Natural log of t plus 4 minus 1 is equal to 1. Well, look up here. The red equation right here represents the natural log of t plus 4 minus 1. So what this is really saying is, when is the red equation's height 1? That's how you translate it. Or the way that I write this down, since you guys don't have color, is when is g of t, as opposed to f of t, when is g of t have a height of 1? And I'm going to write that here for us for our translation. So we'll zoom in so I can write nice, neat, and tidy. What t value when, and this is g of t, right? What did I say? Yeah, g of t. When g is a height of 1. And then I come back up here and I look at the graph. And again, these are always answered graphically for today's lesson and tomorrow's lesson. You don't actually have to do any manipulation because there isn't really one. You have to use a graph. All right, so I'm looking at G, and I'm looking for what is the value of T when I have a height of 1. So when do I have a height of 1? When do I have a height of 1? All right, there. I have a height of 1 right there. What is the T value? I drop down to this T axis, and I say that T value is 3. There's only one answer. There might be multiple. There's only one answer. The answer here is 3. Again, why? It's asking the T value when G, this red function, has a height of 1. Another way of representing this is writing the equation y equals 1. If I have this horizontal line here, y equals 1 means this line that goes through 1. Where does this height of 1 intersect this red line? That's another way of asking the same question. And you'll say, oh, they intersect only at one spot, right there. And the answer is not going to be exact. You can only approximate because, again, it's not perfect. It's a little bit to the right of 3, you can see. But we're going to estimate it's about 3. All right, I don't know how much you guys have followed what I've been saying. So just a 5, where are you guys with this understanding right now? I'm getting 3s and 4s. A 5. A question? Yeah.
So is it x-axis?
Yeah, it's the input variable. I could have called it the x-axis, and if it was g of x.
So t is the x-axis of where?
It's the t-axis officially, but it's the old x-axis. Yeah. They just randomly change it from x to t. All right, so our answer here is t is equal to 3. Oops. Let me change this to t is equal to 3. Let's try another one. I want you guys to help me now. Translate 2 to the power of t minus t squared. Okay, that's a different function. It's one that all these table values are referring to this graph in the top right. So this 2 to the power of t minus t squared is equal to 0. What question is it asking? It's basically the same thing, slightly different. Ellery? There it is. Let's write it down. So it's what t value when, and then I guess the key part that's different now is when f instead of g is a height of 0. At what t value when f has a height of 0? And I come back up to the graph. Let's go ahead and draw the line y equals 0. And let me move this line back up. If I draw the line y equals 0, that's just the x-axis or the t-axis. It's this line right here, this orange line. This line that goes through the t-axis, where does that touch this blue f of t? That's just 1, 2, 3 times. I'll have 3 answers. So I come down here and I approximate them. I say, dang it, I want to leave it orange. I come down here and I say, at t is equal to the following 3 values. Can anyone estimate what those are? Does the quiet raise hand give more participation in here? What are the t values that this blue curve passes through the t-axis? Emily? There it is, yeah, make 1, 2, 4. Write them down. Again, we're estimating here. -1, 2, and 4. There are 3 answers. All right, this next translation is a bit trickier. And there's 2 different ways of translating. There's the graphical and then there's just the pure words. So our new equation is natural log of t plus 4 minus 1, which was that first red equation. And then this equal to 2 to the power of t minus t squared, which was the blue equation. So there's two ways of translating this, and I can wait. I want to see if anyone can get one of them. One person has an idea. How do you translate that? Ellery again? Yeah, and that's the easiest way to translate it. So let's go ahead and write that one down. So again, you're always asking when or what value of t. So what t value when, and I like the way that Ellery said it, f, did you say intersect or cross? F intersects G. Another way of saying that is when do they both have the same height? If you're using the height interpretation. So I come back up to our graph. I can zoom in a little bit. If I look at my graph, where do they have the same height? Where do they cross each other? Well, they cross 1, 2, 3 times. The red and the blue have 3 intersections. So again, I should have 3 t values. I come down here and say, okay, therefore t is equal to the following 3 t coordinates. What are those coordinates approximately? Let's round to the nearest half-ish. Someone aside from Emily and Ellery. What is the t coordinate of this intersection right here, the first one? Yeah. Yeah, it's roughly -1. If you said -1 or -1.5, I would call it correct. So we'll call that -1. What about the next one? It intersects over here. What is that t coordinate? Beverly? Say it louder. Half more than 1, so 1.5. So we can say 1.5. It's a half more than the 1. 1 was right here, 2 is right there. It's halfway roughly in between them. All right, thank you. 1.5. And then what about this one over here? Where's that last intersection? Roughly where? You guys got this? I see Oscar, but I'm going to call someone else. Your estimation skills. Sam, try it.
Wait, where?
This t coordinate, where is it roughly?
4.
Roughly 4. Okay, yeah, let's call it 4. All right. This one is slightly harder. These are the hardest types of questions on Khan Academy today. They're not equal to any number. They're equal to a variable. Where are these variables coming from? The graph. They're always coming from the graph. Look back at your graph. It gave you a random point up here, A, comma, B. Sometimes it's a random point, sometimes it's a point on the curve. This A and B actually have a numerical value. What is A? What is B? Someone tell me. What point was graph right here? What is the value of A? Only one person knows. 2 people know. Oscar?
Would be 1.
A is 1. Why?
That's the x.
Yeah, it's the x part of our point. Goes x comma y. How much right did I go? I went 1 right. So A is 1. We can all come down here and change this problem down here to say, when does 2t minus t squared equal? And instead of A, you can cross it out and say 1, because A is 1. You'll be doing the same thing on the homework. Question, Ellery?
Yeah. A is the x coordinate, so is that different for height, or is it?
It's just a substitution, and you're talking about now, when do I have a height of 1? Exactly. This doesn't mean it's an x coordinate. It's still a height. And then for B, what is B? Come back to our point. What is B? Sorry, Oscar, I'm going to call someone else. Yeah, Beverly. -1. So you come back into this equation, and you say this is -1. even though, I mean, the y coordinates match up. This was a y coordinate and it matches with a height over here. Y coordinates and y coordinates are the same. This seemed like it was an x coordinate, but they converted that into a height. Everything is heights in that equation. All right, so let's move on to the next step. So translating 2 to the power of t minus t squared. It's always asking at what t value, so we can write that every single time, and I can write it for the next one as well. What t value when blank, blank, blank. So I'll write it down here. What t value when the following happens? And I'll just kind of copy paste that into the next cell as well, because it's asking the same question. At what t value when the following happens? And what is happening? Let's look. First of all, which function is this? Is it f or g? To the power of t minus t squared? I'm going to strictly call on someone that I've never called on before. So it's going to be Caroline, Chewy, Jaden, Sam, Aurelio. And Leo, you can if you want to read the objective. 2 to the power of t minus t squared. What color am I talking about? Blue or red? All you got to do is match them. Aurelio, go for it. 2 to the power of t minus t squared. Where do you see 2 to the power of t minus t squared? Blue. So it's saying, when does blue equal? When does blue have a height of -1? All right, write it down. Blue is our f. So we say, what t value when f has a height of 1? Again, everything is always heights. Even Ellery's interpretation of intersecting can be thought of heights. When does f have the same height as g? This is just f has a height of 1. Let's come back up here to our graph. Again, we've already drawn 1. 1 is this yellow or orange line. So when does this blue line have a height of 1? Again, there are going to be 3 values. Those 3 values are what? Where are the intersection between this orange height of 1 with our blue line? These 3 points right here. What are they? Yeah, Leo. So one of them is 1, yep. 1, 4, and you want to get the last one right here? 0, yeah. Leo got them all. Again, you're just looking for the intersection of their heights. You're out of here. All right, someone translate the next one for me. It's the same thing we've been doing over and over. Jaden, you're up. Natural log of quantity of t plus 4, then -1. Is that f or is it g? It's one of those.
Okay, which one is it?
Yeah.
It's G.
It is g. So what value when g, and look at your previous answer. Has a height of not 1 because this one is exactly. So I'll write down Jane's interpretation or translation to say has a height of -1. And then we come back up here. Let's go ahead and graph -1. -1 lives right there. This line represents a height of -1. Anything that crosses this line and G is what we're looking for. Again, G is the red. So we're looking for the intersection of red and orange. It happens right there. Where's right there, Chewy?
It is -1 and 3.
-3, -1. Yeah, so what's the t value?
-3.
There it is. Everyone write it down. T is equal to -3. Oops. Change it back to orange. T t is equal to -3. All right, that's the lesson. Let's do one example. I guess kind of two. It's the same graph though. Give me a fist of 5 before we go on too much further. How well do you have what we're doing right now? Still at 3. We're at 4. 3s all around. 5, 3, 5, 4. All right. Let's try some more. Example number 1. Taken directly from Khan Academy. All right, so I'm giving you 2 graphs. One of them is natural log of t plus 3. That's going to be f of t. So which one does that represent? F is this red. I think it's red or green. I don't know. What is this? Green. Okay. So the green one is our f. Our h one is blue or purple, whatever that one is. We're trying to find solutions to this equation. So I need someone to interpret and then someone to answer. I'll have 2 volunteers here. What does this mean? You can use Ellery's interpretation from our last example. It's very similar to, what was it, the third one that we did? Go back to the front side. It's basically the third thing. Someone interpret. Caroline, you gonna give it a shot? Give it a shot. Look at number 3 and just copy that answer, but kind of add some new stuff in there. The third value in the table where you have one equation set equal to another, right? That's what Ellery did. One value, one equation equal to another equation. So read off the first part. When, yep, it's not f of g now, it's all right, someone help her. I already know that Ellery knows how to do this. She did the interpretation last time. Someone aside from Ellery and Caroline. Yeah, Sam. Yep, the y value of what 2 functions? These ones, right? F and h. So what is the y value when those 2 functions do what though? And use Ellery's word. Just go back and reread this. We're using f and h, so read f and h here.
What t value when f intersects
H, there it is. F and h, look for their intersections. That's what we're looking for. Come back down here. We have 2 functions. Where do those 2 functions cross? There and there. 1 point, 2 point. There's only 2 points that these functions cross each other, where these 2 functions have the same height. Now what's our answer? Well, I see a 3 and a 4. So let's circle something. Obviously, T3 is going to be the answer, right? Let's circle T3. That's one of them. T4 is another. What about Y3 and Y4? Should we circle those as well? Not right now. Can you wait like 5 minutes? Still go.
Because I told him I'd take my photo on Friday.
Okay, I see some of you shaking your head. No, we should not circle Y3, Y4. But look, Y3 and Y4, they're answers. We're circling those points. So why would we not circle Y3 and Y4? Ellery?
I don't know, you told us that it's never the y value.
Yeah.
And it's that because you're only looking at height and the y value. But,
So the interpretation, so you're correct, yes, it's only the t values. Because you're looking at heights, you're trying to solve for what is the input that satisfies this condition. What values of t, or our old-fashioned x, what can I plug in here so that the left side of the equation, the right-hand side of the equation have the same value? Well, if I plug in a y value into a t value, that doesn't make sense. You're solving for a t value because you're plugging in to this original equation. When I solve for this equation, even algebraically, if I could, you'd be solving for values of t. You try to isolate the t. There's no y that you're isolating in this equation, so there's no y values that are going to be answers. It's just values of t. So that's the only answer. Example 1 is just T3 and T4. or T sub 3, T sub 4 is how you pronounce that. Let's try the second one. Slightly easier. Instead of natural log of t plus 3 is equal to an equation, natural log of t plus 3 is equal to 0. What are those answers? First, can someone translate? What is this really asking us to do? When does this function, natural log of t plus 3, which is f, when does f do what? Earlier to give a shot. All right, Elliot, help us. Exactly, f of t. When does this, yes, we green, when does this green line have a height of 0? There's a height of -10, here's a height of 10. Height of 0 is right here. This line represents a height of 0. When does this height of 0 intersect our green line? Where is that? Oscar? Yeah, this first point, T1. What about Y1, Oscar? Exactly, T1, not any values of Y, only T. Done. All right, just judging by the fact that no one has increased their scores from their 3s to higher scores, I have a feeling it's going to be the same, but let's do it. All right, for the entire lesson, our objective was to connect what equations are saying to what the graphs are showing, and then using that to find solutions. So give me a fist of 5 for the entire lesson. See, 3s, 1, 5, what do you got? 3. All right, our average is probably about 3.3. All right, thank you guys.